Well there, hi guys. Just a little one of my little musings here. What I just want to do is just put down on here my thoughts on some of the terminology that we use for when we're knife making, and it's around the process that we use to make the knife hardened as we want it. I'm certainly no expert on this. I'm definitely not a metallurgist. As I've said before, I'm not a gynecologist, but I'll have a bloody good look. But anyway, what I'm going to do is, there's no fancy terminology. I'm not going into all the, the autenzitic and the martenzitic and all the rest of the sort of palaver. Just the basic terminology that's used when we harden and temper a knife. I'm not going into anything fancy, like I say, and this has come about because of the amount of things I've both watched on YouTube, I've read, I've Googled and studied and done as much work as I can over the last 9 or 10 months. And even now I'm finding you see posts on a regular basis or questions that crop up about some of the terminology used, and I think that's the way it's presented and also the way it's used. And from what I've seen, knife makers are atrocious for it. So anyway, one thing I will do is, when I'm talking about the things, I will talk about a critical temperature. That can be anything. It depends on the steel you're going to use, and that's why I'm not talking about specific things. So I will say, for argument's sake, you have to get your steel to a critical temperature or a specific temperature. If you want to know that what that is for your steel, go and Google it, and there's reams and reams of stuff out there from the engineers. I just wanted to put something quite simple and succinct that refers to the main terminology that we use. And I'm going to start with hardening and tempering. And still see questions, oh, is that one process, or what is it you do? Now, hardening and tempering are two very different processes, but they are both required to give you a knife, a usable knife at the end of it. The hardening, you heat the blade to a critical temperature. That changes the structure of the steel. You then cool it very quickly. Depending on how you do that, lots and lots of different ways. It could be in air, it can be in oil, it can be between aluminium staves, it can be with blown air, it can be all sorts of different ways. Again, there's lots of information out there about the specific steel, so you Google hardening your specific steel, and that will tell you the temperature you've got to get to and how quickly you have to cool it down and how. Then, once you've hardened the steel, you then temper the steel. The tempering is done to soften the steel somewhat, because when it's hard it's very brittle, so it's very, very hard, will take a really great edge, but the first time you hit it, smacked or anything like that, or tried to bend it, it will just snap. So the tempering takes some of that hardness out, but then it gives it some toughness, and that's what stops the blade from breaking. And it's the juggling game between the hardening and the tempering that knife makers and tool makers and things are constantly trying to get the last ounce out of the steel. And again, to temper, you take the blade, what will now be becoming a blade, to a specific temperature. You will normally hold it at that temperature for periods of time. That's called soaking. You might do the same with the hardening. Some steels are soaked, some aren't. Tempering, generally you would soak the steel to ensure that whatever temperature you've taken it to is the same all the way through the steel, and that it's relieving any stress in there and toughening the steel. Then normally that will be left to cool in air. So that's hardening and tempering. Hardening, you heat it really, really high temperature, cool it quickly. Tempering, you then take it to a lower temperature, normally hold it, you might repeat temper it 1, 2, 3, 4 times, and then it's allowed to cool more slowly. That's the two processes that then give you a usable knife, and in most cases that's all I've done for years, and obviously that was before I started on the journey I'm on now. But it's turned out knives that are still in use today, like my little Gralikin knife. That's probably 16, 18 years old. It's still in use, still takes a great edge. So it's what you're expecting if you get, when you're buying a knife, will depend on what effort somebody's put into it, and that's the other steps that knife makers and other tool makers might go to. And there are 3 main other steps that people may do. One, or the first one, is called stress relieving. Now, stress relieving, you take the steel to a specific temperature, normally below the temperature you would take, well below the temperature you would take it to harden it, but above what you would temper it at, so it's somewhere in the middle. and then you would allow the steel to cool just in air. And that just takes some of the stress out. That's often done with people who do stock removal methods. And it just takes some of the stress out if you've got it hot during the grinding or the drilling or anything like that. It just takes that bit of stress out. Some believe it helps, some believe it doesn't and don't do it. But that's stress relieving, and I've heard that referred to, just that process, I've heard that process referred to as annealing, as normalising and as stress relieving. But when you read the literature, basically that is stress relieving. The next process that you will often hear termed is annealing. Now, to anneal a steel, you will take it to basically the same temperature you would if you were going to harden it. Then you let it cool very slowly. They might be plunged into warm sand. People use vermiculite. If you've got a computer controlled oven with a regulator, you can set the temperature that the temperature will come down at whatever rate it is per hour. Whatever you do, and to anneal something, it has to be cooled slowly. So that's the difference. You take it to its critical temperature, which is very high, right up with the hardening temperature, but then let it cool slowly. And that's annealing. And what you end up with is a nice, soft, even piece of steel at the end of it. So it's often done by people who do forging, and it's to relieve all the stresses that the forging puts into it. From doing the annealing, they will then move on to harden and temper. The last one of the main group of techniques that you will see used is called normalising. Now, normalising is different again in that you will heat the steel probably to just within its critical range. It can't be below, it has to be just within its critical range, because what happens at the higher temperatures is that the grain structure starts to get smaller and more consistent and even. So if you've got a steel, for argument's sake, 1084 responds very well to normalising. It's quite a coarse, cheap steel, which if it's treated right makes a great knife, and it responds very well to normalising in that it gives it a much finer, more consistent grain structure. Steel such as 01 generally doesn't give you the same results when you're to normalise. It's actually a very high quality fine grained steel to start with. It's also about 3 or 4 times the price of 1084, so you take your choice. And it's completely different makeup as well. Again, when it comes to things like normalising, annealing and stress relieving, really those are steps that you might not need to do. Previously, like I say, I would just stock removal and then harden, temper, and that was it. I'd run probably 2 or 3 cycles of the temper and then leave it at that, and I never had a problem. Touch wood, never had a problem. But like I say, then if you're getting into the forging of the steel, that's when the annealing comes in. If you're doing some, especially because I used to do everything with I had a little 6-inch bench grinder, files, and a hacksaw. There was no real heat involved in it. If you're starting to use mechanical, the big knife making grinders, the 2x72s and things like this, it's very easy to get the steel very hot, and then so then it becomes questionable whether a stress relieving cycle might be good. And as far as the normalising goes, I think you need to have a Google on that, read about your particular steel, what people's experiences are, and find out whether it would help or not. Like I say, 1084 apparently responds very well to it and gives it a much better grain structure. 01 doesn't, because it's already got that really fine grain structure. So that's those processes. I hope that was as clear as mud, and just gives you a little bit of something to think about. And like I say, whatever you hear people on telly, if you hear one person saying, oh, I take my kiln up to whatever temperature and then quench, or a particular colour, Google it, Google your particular steel, and that's why it always helps to know the steel you're using. People make great knives out of car leaf springs, out of old files, out of saw blades. But to get the best out of that steel, you really need to know what kind of steel it is, so that then you can use the right processes for that steel. So, like I say, with that, I will sign off. I hope that was reasonably interesting and didn't completely put everybody to sleep. If you did, please subscribe and like. That would be nice. And I will catch you in the next one. And hopefully this video hasn't got all the things moving around in the background. The last one I did. I've found out I think I was a little bit too close to the wall behind me, and did this in the wall. Learning all the time. Anyway, have an awesome time, guys, and speak to you again soon.